So these were the homework problems, right? Like, can you see my screen? Yeah, I can see. Okay. So these were the homework problems. The first one was exactly similar to the one that we did in class, just a bigger number. Did anyone feel it was difficult? If nobody felt it was difficult, I'll just completely skip the first one and just go to the second one. So first one was easy. Okay, cool. Okay, good. Good to know. Yeah, it's exactly the same one that we looked at in classwork. If you are trying to still pick it up, you can look at what was there in classwork and try to practice that one. How about the second one? Second one is hard. Okay. Okay. Right. Okay, cool. Okay. So second one is the one which we'll try to go over. I'll not use the exact same numbers. I'll use similar examples so that it's I don't have to go all the way up to this number. So I'll zoom in a little bit, hopefully, so that you guys can see. What I'm showing on my screen is right now, there are 1400 multiples. What were the answers? Yes, we'll go through the answers also at the end. There were 1400 multiples of 2, 3, 5, 7, and 11. These are the first 5 prime numbers, right? So 2, 3, 5, 7, and 11, the first 1400 multiples. I just computed all of them. Not such a hard task to do on a computer, right? All I did was put this. And these are the first 1400 multiples of 2, 3, 5, 7, 11. So how many total numbers are there in these 5 columns put together? How many total numbers are there? 1400 times time, and how much is 1400 times 5? 7000. Okay, cool. So there are 7000 numbers. So when I select this list here, if you notice, it says count here at the bottom of my screen. I don't know if you can see it clearly, but the count shows 7001. And if you want, I'll just scroll through all the way to the bottom. So this is the 7000 first row, because my first row had a header. So I have 7000 numbers, right? Straightforward so far, nothing complex, right? I just took first 1400 multiples of each of the first 5 prime numbers and put them together in one big list. Nothing interesting there. Then what I did is I calculated the distinct multiples. Guess how many of these numbers are distinct? If you wanted to make a guess, how many of them? Some of them obviously, like 6 appears in the list of 2 and 3, right? Yeah, we're trying to, Shruti Satya, we're trying to solve second question by seeing what is the question's challenge actually. Because it's not as straightforward as it. What do you mean by distinct? Writing each number only once. For example, if I look at these two lists, 6 appears 2 times, 10 appears 2 times, 14 appears 2 times, right? It keeps, some of these numbers keep repeating, like 12 appears 2 times. So if you notice the multiples of first 7 multiples of 2, only 3 of them never appear in any other list. The remaining 4 of them appear in other lists as well. So that's what I mean by distinct. So writing one number only one time. No, not right now. We cannot look at anyone's solution right now. We can see, we can discuss. If you have any questions about your submission of the homework, we can discuss at the end. So we have 7000 multiples. Of those, lot of them repeat multiple times, repeat on more than one column. So what I did is I tried to calculate the distinct multiples. And if you had to take a guess, how many do you think will be there? How many numbers do you think would have repeated? Out of the 7000 numbers, how many would have repeated? Any guesses? Lot? Yeah, some number, it's definitely less than 7000, right? So what would be a decent guess of how many numbers are repeating? So if you are not willing to guess, it's just about 1800 or 1779 numbers are repeating. So very close. Yeah, actually good guess, Nipun. Very close. So 1779 numbers or 1780 numbers are repeating. And if you notice this, what I did is I counted how many times these numbers repeat. Can you see that some of these are repeating 2 times? Some of them are repeating 3 times also. Do you think any number would repeat 4 times? Yeah, for those of you who have already joined Zoom, can you please write down your full names in Zoom so that we can take attendance? Yeah, so obviously, Satvik, do you think there will be a number that will repeat 4 times? Yeah, 2 times, 3 times. So 210 should be the first number that repeats 4 times, right, Shruti? So 210, where is that? Yeah, repeats 4 times. Does any number repeat 5 times? No, not here in your, not in the chat window. Please rename your login session. Rename your your name in the Zoom meeting to be your full name. So obviously some numbers will repeat 5 times. Let's look at the numbers that have repeated 5 times and nothing else. So I only did as much as 1400 multiples. So some of those did not go beyond. The next time the all 5 repeats is at 4620, so it doesn't go all the way up to there. So yeah, we can discuss individual homework scores at the end. Please don't keep bringing that topic up. We can discuss individual scores. If you have any questions, stay back at the end. We can discuss that. If you haven't seen your score, same thing. If you see some discrepancy, same thing. Homework scoring at the end of the class. So what happens here is, when I asked in this question to add the sum of multiples of these numbers less than this, and each number that's a multiple should be added only once. What I was really asking you is to find out the distinct multiples. So without writing the same number 2-3 times, and add them up. And that's actually pretty difficult to do because some numbers appear 2 times, some numbers appear 3 times. So if a number appears 2 times, if you keep blindly adding it, you have to subtract all the numbers that appear 2 times once. Then obviously you would have subtracted these numbers more than once, so you would have to add all the numbers that are appearing 3 times once again. Then subtract all the numbers that are appearing 4 times, and then add all the numbers that are appearing 5 times. Any of you know what we are doing here? It's something called as Venn diagrams or set theory operations. If any of you have heard of it, just raise your hand so that I know how many of you are familiar with this idea. Okay, I see only like 4, 5, 6 people raising hand. Okay, so if you have heard of these Venn diagrams, what we are really seeing is this kind of a crazy Venn diagram. So if you notice this is the kind of a crazy Venn diagram that we are looking at right now. So right. So you could look at something like this, and this works, right? So this is what is happening. You have some numbers that are just appearing once. Those are at the corners, at the big pluses. Then you have numbers that are appearing 2 times. Those are at the slightly smaller minuses. Then you have numbers that are appearing 3 times. Those are the slightly smaller pluses. Then numbers that are appearing 4 times are in the list. So that's even more smaller minuses. And then there are numbers that are appearing all 5 times. Of course, there is only one number that appears all 5 times. And in the homework you did, we excluded that number. So none of the numbers in the homework really appear all 5 times. So this is really the idea behind the homework problem, that you have to identify these combinations. And there are 31 different combinations actually. Because there are 5 lists or 5 numbers that are there, there are 2 power 5 minus 1 regions in this diagram. And I would like you to read up after the class on some of this, because not immediately right now, but later in the class, maybe in the next a few sessions later, or about 6 to 7 sessions later, we will be exploring some of these ideas even more. And a lot of data analysis is based on this idea. If somebody gives you $1 on Monday and $1 on Tuesday, they only gave you $2, right? Not $3. You can't keep counting Monday dollars 2 times. If you keep counting, okay, I got $1 on Monday, $1 on Monday, $1 on Tuesday. If I write this simple way, so you got $1 on Monday, $1 on Monday, $1 on Tuesday. This is not $3, right? This is just $2. So you don't want to keep adding up the same numbers again and again. That's the problem, and that's a common problem in this idea which we are exploring. This is called sets, and you have to take up the distinct sets to start adding them up. Is that clear? Okay, cool. So now the actual solution to your problem from the homework is fairly long if you do it the first way. So I said it's classwork like loop-based method. It is tedious to type this. It's extremely long to type it. So I still typed it. I went ahead and typed it. This keeps on going. So first I found the multiples of 13, 23 I started with 13. Then I went to 23. Then I went to 47, 79, and 97. This part is really straightforward. Then I went to the LCM of every 2 pairwise numbers. So how many, if you have to take up 2 numbers from a list of 5 numbers, how many pairs do you get? If I have to pick pairs of 2 numbers, so I have 13, what were the numbers? 13, 23, 47, 13, 23, 47, 79, and 97. So those 5 numbers, how many pairs would I get? 10 numbers. Does everyone see what are the pairs? So I get 13 times 13, 23, 13, 47, 13, 79, 13 and 97, then 23 and 47, then 23 and 79, 23 and 97, 47, 79, 47, 97, and 79, 97. So I get these 10 pairs. Now, if I have to take pairs of 3 numbers each, how many pairs would I get? So if I have to get pairs of 3 numbers each, how many pairs would I get? So same at actually, surprisingly or not, it's same 10 numbers. It's harder to write, but it's the same 10 numbers really. How about pairs of 4 numbers? Just 5, very nice. How about pairs of 5 numbers? So there's 1 of these, 10 of these, and 10 of these, and 5 of these, and 1 of these. What's the total? If I add up all of these, 31. Okay. And how many of you know this whole idea? This is something called as Pascal's triangle, or binomial coefficients, or total number of permutations, and so on. 5cn, yeah, it's actually 2 power n minus 1. It's 5cn, 5c is 1 plus 5c2. Okay, yeah, Meghna, what we are doing is we are trying to find out how to solve the homework problem using the same loop-based method that we did in classwork. It's a tedious way to do it because of what we just did so far. Somebody in the can you please switch off your mic if you are not talking? Okay, cool. So because of this number of combinations, we have to account for 31 different numbers. Why don't you count the 5? Isn't the 5 or oh yeah, the number that is our limit. The 5 is 1. For the homework problem that we got, the only number that's a multiple of all 5 numbers is 107,688,139. Hence, we don't really have to count it. Why would we find the combinations of? Yes, Mughal actually, yeah. For those of you who think, why would we find? So let's just take some of these examples here. So let's start adding up, okay? Mughal Shanmugam. So we go all the way up to here, right? If I take the number 30, so let's say I'm adding up all these numbers this way. I got 30 one time, I got 30 a second time, I got 30 a third time, right? How many times did I add up 30? 3 times, right? So how many times should I subtract 30? 2 times. Whereas if I take the number 10, how many times does the number 10 repeat? Only 2 times. So how many times should I subtract the number 10? Only once. So when numbers appear 3 times, we have to subtract them 2 times. When numbers appear 2 times, we have to subtract them 1 time. What to do when numbers appear 4 times? What should we do when numbers appear 4 times? We have to subtract them 3 times. Hence, you have to keep finding out how many numbers appear 4 times, how many numbers appear 3 times, how many numbers appear 2 times, and so on. And the easiest way to find out is calculate the LCM of these two numbers. The factors of the LCM of these two numbers will appear 2 times. The factors of the LCM of 3 numbers will appear 3 times. Factors of the LCM of 4 numbers appear 4 times, and factors of LCM of all 5 numbers appear 5 times, right? Because they'll appear on every one of these lists. If it's a factor of the LCM of all 5, then it will appear in all of these lists. Is that clear? So that's the problem, and that's why any simple solution, if you guys have explored any simple solution or just trying to change your homework problem, that wouldn't have worked. So if you notice, that's the solution really. Add some of them, subtract some of them. So basically it's this idea. So you have to add up all the numbers that appear once, subtract all the numbers that appear twice, add all the numbers that appear twice, subtract all the numbers that appear 4 times, and then add all the numbers that appear 5 times. I would like you to convince yourself that this trick works. If you cannot convince yourself, then this is a very challenging thing to continue. But if you'll have to look at examples and do it by hand, and you'll see that this is what we would end up doing. This is one way of doing it. Of course, there are other ways of doing it. So that's why I found out the LCMs of every 2 numbers, then LCMs of 3 numbers, then LCM of 4 numbers, then LCM of 5 numbers, and then calculated it. When I run this code, it takes about 5.7 seconds. Oh, can I repeat it again? Yeah, so let's take the number 6, right? What I can initially do is I can add up this list and then add up this list and then subtract the multiples of 6 once. If I subtract the multiples of 6 once, that means I only counted, so I'll make all of these colors go away for a second. So I'll just add up these two lists up to here. And then I'll somebody is not on mute. Can you please go on mute if you're not talking? And then I'll subtract.
I'm muting all, then you can unmute yourself.
Okay, hopefully there is no echo. So I add up all the numbers going without looking at it, and then I have to subtract the numbers that appear 2 times, right? How many times do I do that? I just do that once. Why do we add up the multiples of all? Since the multiple should be less than the product of all 5 numbers, because that's the question, right? That's the question is calculate the sum of multiples of 13, 23, 47, 79, 97 less than this number. So there are probably 23 times 47 times 79 times 97 multiples of 13. Oh, can you hear me now? How about now? Can you hear me now?
It's very low.
Okay. 1 second. Let me try connecting again. How about now? Is it any better?
No, still faint.
Pawan, is it any better now? Can be better?
Yes, it is much loud.
Oh, okay, good. Okay.
You can reduce the volume a bit if you want.
Oh, good. Yeah. Okay. So continuing on. Sorry for the audio troubles. So Shruti, to answer the question, we started adding up all the list, all the multiples, right? Because that was the easy trick that we started off with. Just calculate all the multiples, add them up. And then we subtract all the multiples that are multiples of two numbers together. But that leads to subtracting 30. Let's say we go all the way up to 30 3 times, right? So we subtracted 30 3 times. Hence, we have to add it back one time at least. So that we are accounting for 30 at least once. So these numbers appeared only once. These numbers appeared twice. So we subtracted them. But any number that appears thrice, you have to add back. Otherwise, you would have subtracted all the numbers that appears thrice. Does that make sense? Okay. So that's why this whole idea of first calculate the multiples of one number at a time, then calculate the multiples of two numbers and subtract them, then calculate the multiples of three numbers, add them back, calculate multiples of four numbers, subtract them, and then calculate multiples of five numbers and add them back. So if you do that in this long and tedious way, your code produces this gigantic number. That's about 900 to pentillion, 96 quadrillion, 325, no, 902 quadrillion, 96 billion, 325 million, 297,687. So slightly large number. But the program only takes 5.7 seconds if I do it this way still. Now, some of you or most of you seem to have done it another way, where you just use like if it is divisible. We'll go through that method also. That method takes 55 seconds on my computer. It may take different amount of times on your computer. In the same way I use the formula method, guess how long this takes if I use the formula method and calculate all 31 numbers and try to find their, add up some of them, subtract some of them. Guess how long this would take? "30 seconds, 1 minute, 2 seconds." Okay, so it takes 0.02 seconds. So basically almost 0 seconds, right? It takes more time to type the code than for the code to run. So this is again the same thing, comparing efficiency. Some of you could write it in the lazy loop method, which is basically not as fast. How did I figure out how much time has elapsed? That's a good question actually. Someone asked that. So what I do is basically I import this class called time. So let's see this. I'll open a new notebook. So I do this thing called import math. Sorry, import time, not import math, import time. And once I import time, I declare a variable called start time. I say time.time. If I print this start time, it will actually show me how many seconds have elapsed since some fixed time. So this is how many seconds have elapsed, I think, since January 1st, 1900. So most computers count time from some fixed reference. Now, if I run this one more time now, if I call this now and say end time, so now it's, if you notice here, it's been 21 seconds since I ran this loop, because this was ending in 113. This is ending in 134. So basically this took 21 seconds. So all you would have to do is just subtract from end start time. And this would give you 46.449 seconds. If you keep running it again and again, it will give you the same one. So that's what I did. I created a start variable. Is there a debugger in this program? Yes, actually the easiest way to debug in Colab is by creating cells. If I want to, let's say, if I'm having an issue at this point, so I say start equal to 1, start equal to 0, whatever, and I want to debug, if I run all the way up to here, it knows what's the value of start. So if I print start now, you should expect to see 0. So this is the debugger actually. You just add a click another cell, and whatever you want, you continue doing it in that cell. Whatever has run before that will be visible here. So this is how I figured out the time. Basically a comparison of the different methods. The lazy loop method that some of you have tried takes about 9 times longer than the multiple loop method that we explored in the class, which takes roughly about 2,800 times than the formula method that we know. Tanvi, there is no way to do line by line debugging. If you guys are familiar with other editors which allows line by line debugging, you can feel free to use those things. But at the end, you have to share your code in Colab so that we can easily evaluate that. So Kaira Sharma, what is debug? If you are running some program and if you don't know, if we are running something and if you don't know how, if it's coming up with some error, if you're running a program and if it's coming up with some error, the process of figuring out how to solve that error or to troubleshoot that error is called debugging, because your code has a bug because of which it is producing unexpected results. Hence, you debug it. Okay, so that's the idea. So this is the comparison. You can look at the solutions that were posted online. These three methods. Formula method is when you increase the number a little bit. Formula method only went a little faster. Yeah, there are random black marks appearing. I don't know what is happening. Somebody must be drawing who is also a host. So those marks are probably appearing. Then the method that we explored in class, when you increase the number from problem 1 to problem 2, it becomes about 1900 times slower. And the number that, okay, let's see if we can disable annotation. Okay, disabled annotation. Thank you, Shriyan and Prince. So the scalability of the methods, what we really had to, what the main emphasis was basically to figure out how well these methods improve. The easiest method becomes terribly slow. The second method also becomes slow. The method that we first explored in class also becomes slow. Whereas the formula method only is twice as slow as the for first problem versus second problem. So the formula method for the first problem runs in about 0.0009 seconds. For the second problem runs in just about twice as much. So that's the advantage. Sometimes you would have to consider multiple ways to solve a problem so that your program works for big numbers as well as it works for small numbers. So that's the homework solution discussion. If you have any other questions about your own homeworks or additional stuff from last class, we can discuss at the end of the class. Now we'll start on classwork for this class. So looks like all of you got familiar at least with the idea of a while loop last class. Oh, what was the answer for the first part? Let me look up. I don't know what was the answer for the first part. So the answer for the first part was 232,082,151. The answer to the second part is a slight much larger number. So these two are the answers. But not small numbers. Neither of them are small numbers. So now we'll start looking at while loop a little more. Can any one of you, and maybe if you raise your hand, we can call out somebody's name. Tell me the parts of a while loop. Oh wow. So Mohanashri, what are the parts of a while loop?
So first there's while and parentheses.
Okay.
And then you state a condition.
Okay.
And then you put a colon after it.
Okay.
And then you indent.
Okay.
And then you write a set of instructions in the while.
Okay.
And then you print it or break it.
Okay. So you do something. Okay. Yeah. So as someone points out, so let's see, is a condition really needed in parentheses? So I'll say I equal to 0 while I less than 10. Print of I. So what's going on right now? So I started with y equal to 0 while I less than 10 and I printed I and it became an unending loop. So what happened there? I'll try again. It's continuing to run and run and run and I had to basically stop it. So Mohanshri, what did you forget basically?
To break it.
Or to increase it, right? You're not changing the condition. Each time it's the same condition. This was also one question on your test, on your qualification test, right? Basically, you need to increment it by something, or you need to change the conditions somehow. So now it stops at 9, right? This is what we would expect. Yeah, you can do. Yeah, syntax, you guys can all do cool ways, whatever you want to do. So there are really multiple pieces. So this first piece is what is called as loop variable. In almost all loops, there is a loop variable. So you have to first declare a loop variable. Then you write the keyword while and a condition based on the loop variable. You can sometimes base the condition on something else. We'll see that later. And then put this colon. Then there is loop variable change or increment. So there will be 3 pieces: declare a loop variable, write this whole one-line thing, which is while condition, and then loop variable change. Now we'll look at what happens if you, or what can go wrong with while loops. So as I said, 3 pieces: loop variable declaration, loop statement, and then loop variable change. So there are 3 major pieces of a while loop. What kind of mistakes can you make? So let's look at what kind of mistakes can you make with a while loop when you are doing it, and what do you expect will happen. So what kind of mistakes can you make with a loop variable declaration? Anybody, if you want to guess, what kind of mistakes? No, what kind of mistakes can you make? Not what will happen. Infinite loop is what will happen, but what kind of mistakes can you make with a loop variable? That's, we could forget the increment that is here. So forget to increment or forget to change. That's one mistake. Okay, variable, forget to define. So you can forget to define. You can forget the colon. Okay. Anybody else? No indentation. Okay. That we will say, maybe like we'll introduce something here and say loop instructions. No indentation. What other mistakes can you make? Separation. Meghna, what does separation mean?
Like you forgot to put the things in parentheses and break them.
Okay, okay, yeah. So we basically forgot correct condition. Someone else added you don't set a proper condition. Yeah, so don't set proper condition. Okay, so any other mistakes that we can make? Okay, let's see if we make what happens if you make each of these mistakes. Basically, this is all typing mistakes. No, actually, Prince, they're not all typing mistakes. Some of them are logical mistakes. And sometimes you'll see that these logical mistakes, in fact, one of the more, probably these days you guys don't hear about these kinds of things, but in one of the first moon rover missions, scientists used an approximation of pi to up to 6 digits. And when they actually started using this in computations, it led to a division error or an overflow error. It led to an overflow error in computations, and that caused the rovers to crash. So sometimes you can make very, very logical mistakes which are not typing mistakes, and some of these are logical mistakes. So forget to initialize. Sometimes you will have code that runs hundreds of lines and you forgot that you did not initialize. So let's see what happens when you make each of these mistakes. Does anyone want to guess what happens when I forget to define the loop variable? What happens if I forget to define the loop variable? Nothing prints. Okay, so let's see. So I'll comment out this one. So error. Okay, so let's run this and see what happens. So this is a bad idea. I'll say while j, because this already knows that it is I.
So what does it say? Yeah, variable not defined, something like variable not defined. So name J is not defined. So I'm adding a comment to this thing to say what errors we get. Name J is not defined. That's what happens. What happens if I declare this but don't assign any value? So if I just say J, what do you think will happen if I just say J? Now name is declared, still undefined. Okay. So now it says J is not defined still, because this is called declaration and this is called definition. So if I put J equal to 0, so if I forget to initialize the value, sometimes it may give this, sometimes it may give unexpected results also. Sometimes it may give unexpected results. So once I say J equal to 0, now what is the next error I can make? I can forget the colon. So what happens if I forget the colon? Syntax error. Okay, so if I forget the colon, it says invalid syntax. Very good. So I get an invalid syntax error. What happens if I forget the correct condition? So instead of putting J less than 10, I say J less than minus 10. Okay. So yeah, a lot of times it might work, but you might get wrong answer. This is why it is tricky. So might work, but gives wrong answer. But if I give you it completely meaningless condition, like instead of using the variable I, if I use the variable, instead of using J, if I use Y, it would say some other error, name Y is not defined. So depending on what type of error, you'll either get error or may give you an error. Right, so this is more tricky. So this was easy because this will always give you an error of some same specific type. This can sometimes give you an error or sometimes give you, this can sometimes give you an error or sometimes give you different results than you expect. This will always give you an error. This will sometimes give you an error, sometimes not give you an error. How about if you don't set proper condition? That's what we checked here. Unexpected results. What happens if you don't indent the while, the code within the while block? What happens if I do this? Syntax error. Okay, let's see what happens if I don't do this. Let's say I don't print anything here. So this gives expected and indented block error, unexpected indent, good. And then forget to change. What happens if you forget to change the loop variable? Infinite loop, okay. So infinite loop as everybody expected. So if you forget to change, it becomes an infinite loop. So as you see, each error has some behavior. Yeah, will this spreadsheet be shared? Yeah, that's the hope. Last time I drew in Paint and by the end I had erased everything away. So I had to redraw everything, or I gave up on redrawing everything when I shared the class notes. So that's why this time I'm doing in Excel. Yes. So, or you can also make a mistake of changing it incorrectly. What happens if I change it incorrectly? Instead of changing it by 1 at a time, if I change it by 10 at a time, it gives me unexpected results, right? So if I do this, it can give me unexpected results. So we can make these many errors. Yeah, wrong answer. We can make these many errors. Now let's look at the problem from
the qualification test. Now that you guys know this, I would like for each of you to go back and look at this problem in your qualification test and see what's wrong with it. So it started by saying your score on this test is equal to 0, question number is 1. While question number less than 15, your score on this test is equal to your score on this test plus 0.1. Good, Nipun. We didn't increment. So what happens if you don't increment? What kind of error do you get if you don't increment? Who wants to answer? What happens if you don't? Infinite loop. Exactly. So this question on the test, while it looks super easy, actually produces an infinite loop. Why doesn't, where does my loop variable is question number here. So Medha, my loop variable is question number. I'm checking if question number is less than 15, but I never said question number is changing, right? After that, I never changed my question number. I'm just keeping question number as 1. So it's always less than 15. Yeah, in the test, it was a pseudo code Jerry. So it doesn't have colons. It has more English-like stuff in the test. That's why that was, I think, very clearly mentioned. So if I run this code, it will just invalid character in identifier. Somewhere I must have made another mistake. Oh, this is the result of copy pasting. See, all double quotes are not made equal. The double quote I copied from the code is different. So if you notice, it's still running. I don't know if you can see it clearly, but it is still spinning here and it'll keep running forever. By the time Chrome decides to, or Google Colab decides to quit it, make it somehow fail, if it does have such a mechanism. So I never increased the question number. That was one of the mistakes. And then I had to increase the score by 5 points, right? I had to increase the score by 5 points and I had to increase question number by 1. Now, obviously, it will give some answer. So now it prints what some of you thought it would print. You have a good chance to get in, and most of you got in. So these are the 2 fixes at least. So I'll just give a more, if did every one of you get it? Otherwise, maybe I can give you a simpler example, more from real life than from programming. So do you see what goes wrong when you forget or when you make a mistake in each of these pieces? If any one of you have questions, we can take a simpler example which does not involve programming. Okay, so if nobody has a question, then we'll move on to the next part in this, which is sometimes you might want your loops. So let's say you want to continue your loop at the beginning up to 15th question. But let's say this is a test where once you hit 8 points, is there any meaning to score this test? Because if your score is 8 or more, you have a good chance to get in. So does it matter if I have to count your score all the way up to 15, right? Because if your score is 15 or 14 or 13 or 12 or 2 or 1 or 12 or 11, you'll always get the same answer, right? This will just print you have a good chance to get in, right? So should I really make it count all the questions? No, absolutely not. So how do I make? Initially, my goal was to go through all 15 questions. Now I only want to go all the way up to your score becomes 8. But I don't know. But I don't want to change this loop condition. Is there some other way that I could stop the loop once I reach this point? You have to break the loop. Yeah. So some of you probably know this. One of the things we can do is, so I can put this if inside this loop, print this, and as soon as my score increases beyond 8, I call this thing called break. So now what happens is the loop does not go beyond 8. Everybody's score, once it reaches 8, it just says you have a good chance to get in. Forgot to change loop variable. So this is what is meant by forgot to change loop variable. So if I don't increment it, so if I forget to do this line, I don't know if you can see my screen clearly. I'll zoom in a little bit. Okay. So this is the loop variable. If you forget to change this, then it will become an infinite loop. What happens when you put if loop inside the while loop? So if, yeah, this is exactly what happens. Let's see what happens. It prints this, and then this, it broke, and then it went to this else also. Oh, so sorry, this is, let's see, your score on this test, better luck next time. So this else should not be inside this. So what happened here is it starts the test, your score on this test is less than 8, then it says better luck next session, and then it goes back, your score on this test is greater than 8, and it says you have a good chance to get in. So see, this also led to some logical error, right? The first time it ran, it checked that the score is less than 8, because the first time it ran, the score is just 5. It printed better luck next session. And the second time it ran, it became 10. So you said you have a good chance to get in, and it stopped running after that. So what happens if you put code incorrectly like this? It will give incorrect results like this. So ideally what I wanted to do in this case is to say something like this. So I have to evaluate all the questions and then check the score to say print better luck next time. So Shresh, actually it depends on, isn't using break considered lazy programming? It depends on why you are using. You can use it for lazy purposes, or you can use it for very meaningful purposes, right? In some cases it is for lazy purposes, in some cases it is for meaningful purposes. In this case, I'm trying, could you explain why that was going wrong? Yeah, so let me show you what was going wrong again. So I put an else and I put this here. So can I say, as soon as I correct the first question, your score obviously will not be more than 5, right? Because the first question is only worth 5 points. So as soon as I correct first question, should I say better luck next time, or should I wait till I correct all the questions and see the score? So I should wait, but here I didn't wait. When I put this if else within the while loop, I didn't wait at all. I just corrected the first question and said better luck next time, bye bye. So it printed that. So if ideally what I should do is I should check. If I have a greater than 8 score, then I just say you have a good chance to get in, I stop it. But at the end of the while loop, after finishing the entire while loop, I have to check if your score is less than 8 still, then I say better luck next session. So that's what, sometimes you can make very seemingly simple logical errors, right? And this is not a typing mistake, this is a logical error. And when you make a logical error, you get unexpected results. No, it is quite possible. Your AP computer science teacher might have told you to avoid breaks, because a lot of times people use breaks in incorrect situations. So it's very easy for your teacher to say always avoid break, rather than having you, it's like saying always stop at red light. But why does an ambulance not stop at a red light? Right? So it's the same thing. It depends on the situation, but if you give that option to everybody, then they would all behave like an ambulance and not stop at red light. So your AP computer science teacher is also right when they said, okay, avoid breaks, but it has a purpose. So don't use break always, otherwise it will break your code. But if you absolutely have to use it, sure, feel free to go use it in emergencies. but don't use it as your first resort. Then it will break your code constantly. Yeah. No, we don't need to have, we don't need to have the else statement here. No, it doesn't necessarily break the code. It is what Shresht was referring to is slightly older practice and what is now programming mistakes to avoid. Some older programming languages, break causes havoc in how the languages work. In compiled programming languages, if you break, it causes a lot of problems. In interpreted languages like Python, break is not really such a big deal because Python is not really trying to do, you are using Java. Java is a compiled programming language, and in that it causes a problem really, because when you're running code in Java, it doesn't go line by line like what Python would do. It's almost like Java is almost like trying to say a book that is translated from English to Spanish, and you put a break on 20th page. It actually ends up going all the way to the end of the book. That's what it is. So you don't want to say break in between in compiled programming languages because it causes performance problems. But this is like a translation in real time. While translating in real time, if the translator wants to take a break and sip some water, that doesn't do any bad, right? So without going further, why the break command does. So Meghna, what the break command does is it will stop your loop from running any further. So if you have a loop that runs 15 times, here we expect the loop to run 15 times. And if we want to stop it prematurely, then we add some other condition to use a break and stop it. It's useful in some situations. Yeah, you can change whatever you want. You can check the questions. So maybe I only want to check all the way up to 10th question. And I just say, okay, if you have attempted 10 questions, good enough. Don't even bother. I'll just say you have a good chance to get in, right? So you can customize whatever this condition is. You don't have to really use one kind of condition. It depends on what program you're writing, really. Okay, so now moving on. In this class, in the next 45 minutes or so, all of you, we will be solving this second classwork problem. Yeah, Prince, yes, there is a function for random number. We will get to that and use it a lot in about 10 more classes. And you guys, I don't know how much you have used random functions. We will use lots of random functions in 10 more classes or so from now. So hold on till then. So this class's problem, the problem we are going to solve in this class and explore while loops a little more, is printing Fibonacci numbers. How many of you know what is a Fibonacci number? Or how many of you don't know? Maybe that's an easier question. How many of you don't know what's a Fibonacci sequence or Fibonacci number? How many of you don't know? Please raise your hand if you don't know. Okay. So a few people don't know. So we'll start with the Fibonacci numbers. So this was another question on your test. This is why basically I was asking some of these questions so that we can use those to see if you guys knew or not. So most of you knew it. Yeah, very good, Satvik. So starting with the number 1 and 1, the Fibonacci sequence is basically adding the two previous numbers. So what is 1 plus 1? 2. Then two previous numbers, 2 plus 1, 3. Then two previous numbers, 3 plus 2, 5. Then two previous numbers, 5 plus 3, 8. 13, 21, 34, 55, 89, 144, and so on. What's the next number? Right? So some of you might have already watched this number file video or some other video online. How big is this number compared to the previous number? So if I divide this number by the previous number, it's 1.5 times. So if I keep adding up this number, so if I continue this formula a bit, and if I continue this a bit, do you notice some pattern here? Yeah, Shruti Satya, yes, it's about 1.61803. How many of you know what's this number? This number has a name actually, 1.61803. This golden ratio, yeah. So this number has a name, it's called golden ratio. If any one of you have watched the a popular Dan Brown novels adaptation, it's called Da Vinci Code, you probably have seen this in movies. You might have seen it in other places. This is the ratio of the length of the width of your shoulders. If you stretch out your shoulders, the distance between the two tips of your fingers at the ends to your height of the torso or something. It appears a lot of places in nature. This is called golden ratio because it's so frequently seen in nature. You can actually watch, there are lots of good videos online which will probably explain to you how to calculate the ratio of this. But the general idea is actually fairly straightforward. Let me see if I can share my whiteboard. Can you guys see my whiteboard now?
No.
Okay. Okay. How about now? Can you see it? Just a white screen. Okay, doesn't work. Maybe that will. Okay, you can see. Okay, great. So let me see if I can write on it and see if we can see something. No, so hard to write on there directly. Okay. Yeah, I'll have to figure out by next class. I'm sharing two screens, so hopefully I'll have to figure out by next class what to do with this. So if you start with a Fibonacci number, call it f of n. Some of you may know this notation. If you don't know, that's all right. You can look up online. There are a lot of videos to see this. You get f of n minus 1 plus f of n minus 2, right? So this is what is called as a recurrence relation. This is how Fibonacci numbers are generated. What we want to calculate is f of n divided by f of n minus 1, right? And that's just equal to 1 plus f of n minus 2 divided by f of n minus 1, right? No, this is not about storing actually. This is not about storing, Nipun. This is about calculating. So yeah, you can obviously store in arrays. There is no big deal. So this is what is called a recurrence relation. So any number I'm calculating as the sum of the two previous numbers. We are not storing anything at this point. Yeah, we're not storing anything. We are just trying to calculate why this is becoming this 1.618. It looks like it is becoming 1.618 constantly, right? So we are trying to really see mathematically how that works. But if this number is x, what is the number on the right side? What is this? If this is x, this number is 1 over x. If this one is x, because here you are taking nth number and dividing by n minus 1th number. Here you are taking n minus 2th number divided by n minus 1th number, which is the same as 1 over f of n minus 1 by f of n minus 2. So it's the same as 1 over x. And you can see this, you don't have to believe me. As you can see, the ratio of these two numbers is the same as ratio of these two numbers, and it's happening, right? So that's why we can just say it's 1 over x. So x equal to 1 plus 1 over x. This becomes x square equal to x plus 1. And those of you who know how to solve quadratic equations know that this becomes x equal to 1 plus or minus square root of 5 over 2. I'll not go into how you solve this. You can solve this with quadratic equations. Yeah, so I'll explain again. This is what is called as recurrence relation. And the reason why we are doing this is because this is also a very fundamental programming idea. Recurrence relations and computations are a very fundamental programming idea. You may or may not have seen this in your computer science classes in your school. But any number is the sum of the previous two numbers, right? This number is the sum of these two numbers, right? So when I want to divide this number, so this number is equal to sum of this number plus this number. Right? Then I want to divide this number by this, which becomes the same as 1 plus dividing this by this, right? But we already know when you divide, so this we already are seeing is 1.618 is equal to 1 plus 1 over 1.618 is what I'm claiming it to be. Oh, you can't see? Okay, let me switch sharing. How about now? Can you see my screen, my Excel now? Oh, okay, yeah. So basically what I was doing is 1.34 million. This number is the sum of these two numbers. So when I want to divide this by the previous number, 1.34 million divided by 83,000 or 832,000, I get 1.618. That's the same as doing 1 plus 514,000 divided by 832. But when I divide these two numbers, it's the same as doing 1 over 832,040 divided by 514229. So if this is x, this is 1 over x. Hence we get the quadratic equation, which when solved gives us that relation that we got. So this is the secret. Now, without worrying about this, what we want to do in this class is to print Fibonacci numbers. How far do you want to go? How many Fibonacci numbers do you want to print? You guys can choose. How many Fibonacci numbers do you want to print? Ask the user. That's a little complex. No, Mohanshi, 2000 Fibonacci numbers are really large. Okay, 50. Okay, Hari Gisan says 50. Okay, let's print the first 50 Fibonacci numbers. So you guys can all start programming. Actually, before you start programming, let's see how do you do it by hand. So that's what we mentioned last time, right? How do you do it by hand if you are doing it? So how do you do it by hand if you wanted to start? So first you start with some Fibonacci 1, right? Fibonacci 1 and Fibonacci 2, two variables. You start with that. Set both of them to be 1. Then what do you do? Then you can calculate Fibonacci 3 to be Fibonacci 1 plus Fibonacci 2, right? Can you see what I'm typing in this Excel file? Okay, so this is just Fibonacci 1 plus Fibonacci 2, right? So if I want to start this in a programming thing, I can declare a variable fib1 equal to 1, fib2 equal to 2, or 1, and fib3 equal to fib1 plus fib2, right? Now what do I do next? Once I calculate this number, this became 2. Now I want to shift all the numbers right. So I want to make Fibonacci 1 become Fibonacci 2, then Fibonacci 2 become Fibonacci 3, and then repeat this same instruction, right? So I'm transferring the numbers. So after that, after I finish 1, 1, 2, I want to take up 1, 2, and then add it to become 3, right? So I'm transferring this number from here to there, and then transferring this number from 3 to 2, right? And you can do that easily with variables. So I can say fib1 equal to fib2 and fib2 equal to fib3, and then again say fib3 equal to fib1 plus fib2. Does this seem reasonable, or is this does this code look like I'm not doing it right? So does this code look like it's correct? So I said fib1 equal to fib2, fib2 equal to fib3, and then fib3 equal to, yeah. So I just can repeat this again and again and again. So now that you guys already know what, if I'm repeating code again and again and again, what can I do? To save repeating myself again, loop, I can use a loop. So let's see if this prints correctly. So it printed 2, 3, 5, 8, 13. That seems like correcting. So now that I told you the basic idea, you guys can start programming this with a while loop. But your while loop has to print up to 50 Fibonacci numbers. And then you start, once you have finished this, you can start sharing your answers after 11 o'clock. Don't share your answers till 11 o'clock. All of you, till 11 o'clock, you can stop. Okay, so start in the first 11 minutes. If any one of you gets, then you stay till then. So our goal is to print the first 50 Fibonacci numbers. Print first 50 Fibonacci numbers. And all of you guys can start. Yeah, we're just printing it, not finding the sum. If you want to find sum, Shruti, absolutely, you can go ahead and find the sum. Yeah, for those of you who have printed already, or who already know how to do this, you can try the more challenging variations of that problem. Do we have to explain after 11? No, you can start you can start sharing your answers after 11. But for those of you who already have printed the first 50 Fibonacci numbers, try these two, actually try these three slightly more challenging variations. The first challenging variation is sum of first 50 Fibonacci numbers, or sum of Fibonacci numbers less than 4 million. So the number itself should not be more than 4 million. You have to add up all the Fibonacci numbers that are less than 4 million. That's the first slightly harder variation of the same exercise. The second one is ratio of consecutive Fibonacci numbers. Third one is ratio of consecutive even Fibonacci numbers. These problems are only for those who have finished the first problem. First finish the first 50 Fibonacci numbers. Then if you want to go, you can go and try these remaining three. Each one is increasingly more difficult than the previous one. Yes, you have to print fib sequence within the loop. Yes. No, the starting two numbers are 1 and 1. You can start off with the first two numbers, both are 1 and 1. Mohanashri, the number itself, the Fibonacci number itself has to be less than 4 million. Why don't we start off with 0, Meghna, so that all of you get the same 50th number? I started with 1 and 1. so that my 50th number will match your 50th number. If you start with 0 and 1, your 50th, my 50th number will be your 51st number. Shreyan, you don't even have to show. If you just paste your answer in the chat window, if others also paste the same answer, then it's correct. If you paste one answer and somebody else pastes another answer, then it's a different answer. Then we will discuss. It depends on how many of you get the same answer. I'm hoping there is only one answer. If all of you start with 1 and 1, there is exactly one answer. Tanvi, for the second problem, should the numbers be less than? Yes, Tanvi, for the second problem, number should be less than 4 million. So each of the Fibonacci numbers that are less than 4 million, you only add up those. Shreya, if we start with 1 and 1, the first number becomes 2. So Shreya, if you start with 1 and 1, the first Fibonacci number is 1, second number is 1, third number is 2. So that's the counting, Shreya. So when we are counting, the first Fibonacci number is 1, second one is 2, third one is, first one is 1, second one is also 1, third one is 2. Another 6 minutes later, Shreya, you can paste it 6 more minutes later. At 11 o'clock, those of you who already think they got an answer, at 11 o'clock, you can start pasting. But don't paste till 11 o'clock. No, you don't have to paste your code. You just have to paste the number, the 50th number. Yeah, I went back to code. So the idea is you start with this, then you keep repeating these 3 steps. Start with these 3 as the initial starting point, and then you can, you just have to paste your output. You don't have to paste the code. And then you have to repeat these instructions till you get the 50th number. I won't tell you how to find out where you got the 50th number, but you have to repeat these steps till you get the 50th number. Yeah, of course, you have to use a loop. Yeah, unless you want to copy paste this so many times, you have to use a loop. Yeah, use a loop, but you start with the first three values are computed before your loop starts. But you use a loop after that. Yeah, sure, Nipun. Are you trying to do something like x equal to x plus y, y equal to x plus y kind of thing? Yeah, it's not necessarily any faster. If you use that method, actually doing this, you can't do this actually if you use your method. Nipun, try doing this third problem if you can with that method. It becomes very hard. Is the ratio of the consecutive Fibonacci number the average of the ratios between two numbers? No, you just keep printing the ratios and then notice whether the ratios are becoming the same after some point. So print ratio, I'll just say print ratio of consecutive first 100 consecutive Fibonacci numbers. So now hopefully this question is more clear. Then print ratio of first 30 consecutive even Fibonacci numbers. Okay, 2 more minutes. Those of you who already got the answer to the first question, you can start pasting at 11 o'clock. That's in 2 more minutes roughly. If any one of you are having difficulty, please raise your hand and maybe we can help you. We can set up a separate breakout room and help you there. Okay. Okay, people are raising hand. 1 second, I'll see who is raising hand and who is chatting. Okay, 4 or 5 people have raised hand. 5, 6. How do we raise hand? Actually, no, Ish, I said the number should not be more than 4 million. Answer is definitely much more than 4 million for the second question. Okay, Mega Vignesh. So, Shriya Kalyan, if you are logged in as host, can you start splitting some of these people like Avnish, Ravan, maybe along with Balaji or Avne and others which should, like two people who have raised hand into a separate breakout room with Balaji or with Shubham.
Hey, you want to do it or you want me to do it? We can't hear you. No, not really.
Oh, right. Guys, you don't have to paste all the numbers. Please just paste the last number. Otherwise, nobody can see any of the answers. Please just paste the 50th number. If you have already gotten an answer, just paste 50th number. Okay, straight up.
Yes, maybe so.
Yeah, Pavan or Shriya, one of you, can you start breaking out into rooms?
Okay.
Okay, as expected.
I'm adding these with Balaji.
Okay, yeah. So as expected, some of you are getting different answers. Let's see which is the most unanimous answer for the 50th number. So far the 533 number seems to be the one that most of you are getting. Some of you are getting 200 million. My code is taking a long time, but I don't know why. Did you put a break in your code, Shaishya? Because after you reach 50th number, you probably have to break. Do you have an end to your while loop? If any one of your code is just continuously printing numbers after numbers after numbers, that must mean you have an infinite loop. Okay. So far about 10 to 15 of you shared the answers, and there are 4 to 5 answers. So let's see how many answers are the same. My code is taking a long time. Okay. So let me see what is my answer. I don't know if it's matching. If any one of your answers are matching my answer. Fortunately, none of your answers are even matching my answer. So actually, no, maybe Jerry. Yeah, Jerry's answer matches my answer. So the popular answer is not matching my answer though. Jerry, Mugil, a few others. Angela's answer is slightly more than mine. Nipun, Jerry, Mugil, Simran, Angela have the same answer. So I think Shresht, all of you who got the answer that starts with 533, I think you went 2 more numbers ahead. You probably did not consider 1 and 1 as the first 2 numbers. For those of you who got 203 answer, I think you went 1 number ahead. For those of you who got the 125 answer, you guys did exactly till the 50th number. For those of you who got the 329 answer, oh, you went 2 numbers ahead. 533 people, you went 3 numbers ahead. So some of you printed exactly 50th number, some of you printed 51st, some of you printed 52nd, 53rd. That's a very interesting thing. Let's see how many of you print 51st one. Now a lot of you are printing 50th one. Okay. Matthew, yeah, 1 second. Matthew needs some help. Yeah, I'll show the code in a few more minutes. Around 11:10 we'll start seeing a code. Yeah, around 11:10 we'll start. Till then, please try. The whole idea is for you to try. Yeah, perfect reference. So basically, just to give you a hint, so that you guys can proceed further. Here you have to introduce a loop variable, right? What is my loop variable? My loop variable is count of Fibonacci numbers. So I'll say count, and at this point in my code, my count is 3, right? So I started with first Fibonacci number being 1, then another Fibonacci number being 1, then the third Fibonacci number being 3. So at this point, my count is 3. Then I simply say while count less than equal to 50, or while count less than 50, and I repeat this loop. Oops, didn't mean to scroll so fast. And I repeat this thing and keep printing it. Then I have to do something to count. Each time I calculate, I have to do something to count. So that's the general idea. It's a very short code actually, but the idea is what is powerful really. So a lot of times you can make computer do a lot of stuff with just a few lines of code. So the answer to the second question, I don't know. Jerry, the answer to second question cannot be 3.52 million. That's the number. That's the largest Fibonacci number less than 4 million. But I want you to add up all the numbers till there, Jerry. So if you calculated the number to be 3.52 million, the sum of all Fibonacci numbers till there. Oh, can you see the while? No, not really. That was only a hint. So the general idea is you start with count equal to 3. You start with count equal to 3 and then you put a while based on the count. Repeat these 3 steps. So I'll even leave the while condition based on count. And then you do something to the count, some change count. So that's the hint or general idea of the code really. Oh, what are all the questions? Sorry, I probably scrolled a little too far. So the second question, for those of you who have gotten the 125, the number starting with 125, that's the correct answer. If you haven't gotten that, focus on that. Otherwise, if you got it, you can move on to the second question. Find the sum of all the Fibonacci numbers, sum of all Fibonacci numbers that are less than 4 million. So it looks like Jerry already found the largest Fibonacci number that's less than 4 million, but we want to add up all of them. So for those of you who have already printed all the numbers up to 4 million, so I want to add up all these 33 numbers. So the 33rd Fibonacci number is 3.5 million. I want to add up all these 33 numbers. Is the answer for number 2? Let me check, I don't know. It's 922. The answer for second question is about 9 million. Yeah, Jerry's, that is correct. Yeah, Jerry's answer is correct. It's 9.227464. Does anyone else still need help? Please raise your hand if you need help figuring out this current question. If you don't know how to raise hand, okay. Shriya Kalyan, can you maybe send. Can you please go back to code? Okay, I will go back to code. Yeah. So these 2 lines are what you really have to do something, because I already gave the rest of the code. You have to really do something in these 2 lines of the code. What is the stuff you have to type in this line and this line is the question really. Oh, okay, no problem. Yeah. Can somebody, Pavan, can you move maybe Pavesh Shaktivel to another breakout room with Shubham?
Sure, I'm starting it.
Anyone else who has a question, please try to. Oh, okay. Oh, sorry, Shubham. Oh, Balaji is in breakout room. Oh, okay. So Balaji, if you are done, we can't hear probably.
No, Balaji will not be able to hear.
Yeah,
So
yeah.
you want me to move him with Balaji or?
I don't know. He says he's in with 3 students and he can't hear.
Okay.
If you are done.
Shubham is available or not?
Yes, I'm available.
Okay, I'm assigning it to you.
Okay, yeah, Mugil, the answer I think is correct. Yeah, Mugil, your answer is correct. Shruti Satya, what was? Oh, Shruti Satya, your answer to first question is correct. Yes. Nipun, yes, your answer is correct, Nipun. Mohan Shri, for the second one, no, your answer, I think you added one more number, Mohan Shri. You went up to the 34th number. So you added extra 5 million. How do we do the ratio thing? Jerry, the way you do the ratio thing is as you find these numbers, right? Print fib3 divided by fib2 as you find it, not after your assignment. So you could find it that way. It's just division, right? You're finding the numbers and then you divide those numbers. Answer for number 1. We will discuss answer in like 5 minutes. But please try it for another 5 more minutes, Kavya. You can print whatever, you can paste whatever answer you got and I'll tell you if it is correct or not. For the second question, yes, Sanjukta, that's the correct answer for second question. Sanjukta, Nipun, Mugil, Jerry, all of you got the second question correct. I don't know if anyone else got it. Yes, Shruti, that is okay. If you make the count less than or equal to 49 and you're getting it, that's probably okay. Shriya Rajesh, that's the correct answer for second question. Kavya Sriraj, that's the correct answer for first question. Yes, Maulud, that's the correct answer for second question. Yes, Aditya, that's for first question. Yes, Varsha, your answer is correct. Any one of you, if you're trying the third question, please try the third question. Those of you who already got the second one, try the third one. Yes, Meghna, that is correct. Your second question answer is correct. So you have 4 more minutes. Those of you who want to solve the second question, if you did the first one, go to second one. If you did the second one, go to third one. For number 2, should the sum? No, the number should be less than 4 million, Shruti Satya. For question 2, each number. So there are 33 Fibonacci numbers less than 4 million. Add up all of those. Okay, guys, we have 3 more minutes. If you guys have any questions. Yes, Satvik, your answer is wrong because you went one extra number, Satvik. You went just one extra number. Third question, 158. Jerry, what did you do? Oh, wow, 158. I don't know about that. Third question, Jerry, it looks like you calculated the ratio somewhat differently than what I was hoping. Yeah, Meghna, the third question is this. If you can see the Excel file that I'm sharing, as you calculate Fibonacci numbers, I want you to divide the number you calculated by the previous number. Number you calculated by the previous number. So Fib3 divided by Fib2. So in this case, I would want to do fib3 divided by fib2. And then after doing this calculation few times, I also want to do the same thing. So Meghna, whoever got it, first one, no, Satvik, first one, that's not the correct answer. For those of you who are getting a number starting with 3.92 for the first one, you are going one extra number or probably two extra numbers. I don't know how many are going extra. So for those of you who are looking at my screen, I'm just repetitively printing fib3 divided by fib2 and I'm getting a better and better answer. Yes, Shruti Satya, that's the correct answer for the second question. Oh, Satvik, you pasted the wrong answer. Okay, no problem. Okay, we are at 11:15. So let's see now what to do. Okay, perfect. Yes, Shruti. Yeah, that's the correct answer for question 1. So for those of you who are done, congrats, good job. You did it well. Rohan, that's the correct answer for question 2. That's good. For those of you who did not get it, that's fine. Keep trying. And this is more about practice. A lot of this is about practice. If you keep doing, you'll get it. So what are we really trying to do here? Yes, Lucky, that's the correct answer. Darren, Lucky, that's the correct answer for your questions, for second question. So I want to go all the way up to 50th number, right? So I'm starting at the third number. I want to go all the way up to 50th number. So each time I go through the loop, I'm doing count equal to count plus 1. So let's see what I get if I print this. So I got this 125, the big number starting with 125, right? So 12586269025 is the 50th Fibonacci number, starting with 1 and 1. It is very important that you all start with 1 and 1 and not at 0 and 1. If you start with 1 and 1 and call them the first Fibonacci number, second Fibonacci number, and 2 is the third Fibonacci number, in that case, you will get this 12586269025 as the 50th number. I did this in Excel also, so Excel, same thing. Hari, if it is continuously repeating for you, you probably didn't use this count correctly. So you are not stopping your loop anywhere. You probably didn't increase the count equal to count plus 1. So this is the first question's answer. Okay. Now, a good example of where you can use break without being lazy. So the second question is a good example of where you can use break. Do you know when will you hit 4 million in the Fibonacci numbers? So which Fibonacci number is more than 4 million? Is it the 10th Fibonacci number? Is it the 20th Fibonacci number? 33. Perfect, Mugil. 34th is more than 4 million. But that's because you already did it, you know. But before you did it, did you know? Yes, Jerry, that's the correct answer for 3. So before you calculate the sum, as you're going through Fibonacci numbers, you really don't know whether 4 million is the correct. When do you hit 4 million? Yeah, Mohanashri, we'll go through all the questions in the class now. Hari, please see what I'm showing. Can you see the code I'm sharing, Hari? The code I'm sharing is printing all 50 numbers. So we start with count equal to 3.
Hey, Karthik,
Your audio is bad.
Sorry, what's that?
your audio went down again.
Oh, okay. Let me see.
It's better now. It's better now.
Oh, every time my screen switches off, it's going. I don't know. Okay, cool. So we started off with the first.
It's bad again.
Didn't change anything. Okay. So we need to figure out something. Is it any better now? Okay, no problem. Let's try. How about now? Is it any better?
Yep.
Okay, I'll try this way. I don't know.
Okay, so we started with the up to 3 numbers already declared. And then we went to up to 50th number. We are increasing the count by 1 because within each loop, we are just finding one more Fibonacci number. Yes, Nipun, that is correct. So now I want to change the same code to calculate the sum of the first sum of the Fibonacci numbers less than 4 million. I don't want to keep writing another code. So I start with this. Before I go into the loop, I'm going to say my starting value of sum is the sum of the first 3 values, right? And then I check if Fib3 less than 4 million, 1, 2, 3, 4, 5, 6, sum Fib equal to sum Fib plus Fib3. So I didn't change my, I reused most of my program. Hopefully it will bring the correct answer. Let's see. So it printed 9227464. Right. So Hari, I'll copy this code onto the chat window. You try to use the code as is and see if it works for you. So I copied the code, Hari. Try to use the same code and see if it works for you. So I'm going to comment out this print Fib3 because in this case, I don't want the Fib3 really to be printing again. I just want the sum to be printed. So it did it and it printed this answer. So answer to the first question is this. So now I'm showing on my screen both the answers to first question and second question. So see, you can reuse your code a lot of times, and that's the idea that I would like to convey really, because if you don't reuse your code, it becomes very difficult. If you always have to start typing from the beginning, what is the third question? Yeah, the third question is, as you calculate 2 Fibonacci numbers, I want you to divide the bigger number with the smaller number. Bigger number with the smaller number, bigger one with the smaller one. So basically it's just printing Fib3 divided by Fib2. Just to see if originally when I did it in Excel, it looked like it was all, the right word, technical word is called converging. It looked like they were all converging to a fixed value. We want to see what they are converging to. So if you notice here, all of these are really essentially the same value, really. Yeah, some of you might get a lot more digits than what I can show here. Yeah, perfect. So if I just do Fib3 divided by Fib4, Fib3 divided by Fib2, it looks like the value already starts going closer and closer to 1.618 here itself. And then it goes to 1.618. So if I graph this thing, I'll copy this, put it in Excel and graph it. Too bad, Excel is very. So I'll just do it in my Excel sheet that I already started. And if I graph this thing, so can you see this graph on my screen? Oops. So it started being 1.5, then it went all the way to 1.66, then dropped again to 1.6, then increased to 1.625, dropped, and then it is almost flat, right? This is what is called as convergence. Some of you who already are studying limits and calculus may have an idea of what this means. This series
the ratio, basically the ratio of two consecutive numbers in this series converges to 1.618 and something. And this is visual evidence that this is converging. You can do this as by just simply with this code and plotting that numbers. Yeah, you can get a longer one. On my computer, when I'm printing, it's only printing up to 12 digits or 14, 15 digits or whatever. You can get like 100 digits printed out of this if you really want to do it. Depending on how you are printing, it might be showing you a lot more. And depending on which code editor you are doing it, it might print more digits than what you're seeing here. So these are the first three questions really. But in the third question, we wanted to go up to 100. So you would just change it to 100 here. No big deal really. Now the last one is the hardest one really. So I want to get the ratio of the first 30 consecutive even Fibonacci numbers. Can you show the code for third one again? This is the code for third one. All I'm doing is just printing the ratio. That's all. I'm not doing anything fancy anywhere. I'm just printing fib3 divided by fib2. That's all. The same code that all of you used to find up to the 50th number. I just changed the print in that to, instead of being fib3, I just am printing fib3 divided by fib2. So just one extra comma to your code and this thing. So no extra steps really, just one extra comma and one calculation. In fact, the same number of lines as your original code. This is a little harder. The reason why it's harder is because of this. Can you see Fibonacci numbers back again on my screen? Can you see the Fibonacci numbers again back on my screen? Yeah, okay. So the first even number is here, right? The first even Fibonacci number is here. Where is the next even Fibonacci number? 8. So that's here. Where is the next even Fibonacci number? 34, right? At 9th position, right? The next one is here at 144. So what's the gap between any two Fibonacci numbers? Skip 2 numbers, right? Yes, perfect. Skip 2 numbers. So if I call this as fib3, so if I'm calling this fib1, fib2, fib3, right? This is 1, 2, 3. This is 1, 2, 3. This is 1, 2, 3. 1, 2, 3. So even numbers appear at 3, 3 gaps, right? Or every third Fibonacci number is an even number, right? So this, when I gave the names of variables, this was fib1. The variable name was fib1. The second variable name was fib2. The third variable name was fib3. So to get the ratio of two even Fibonacci numbers, which variables do you have to divide? So to get the ratio of two even Fibonacci numbers, which variables do you have to divide? Fib3 divided by fib3. And obviously all of you who know what is a variable division, what happens when you divide x by x? What do you get? 1, yeah. So that's the problem. So you almost have to, right, you have to declare fib6, but in our code, we don't have a variable called fib6, right? We only have 1, 2, 3. In the code, you don't have fib6. Since you don't have fib6, we have to come up with a way to somehow remember the value of fib3, right? So we have to remember the value of fib3, use a temp variable, absolutely. Some of you seem to know these tricks already. So for those of you who don't know, what we can do is we can say fib even. I give a new variable called fib even, and I set it to fib3 because I know in this case it's the same as fib. Every fib3 will be an even number. I know that, right? But not every fib3, sorry, not every fib3. Every third Fibonacci number will be an even number. So when I say if count percentage 3 equal to 0, Then I want to print fib3 divided by fib even and set fib even equal to fib3 so that it remembers the next one. Does this work? So when count is here 4, 5, and 6, let's see if this works. So what I'm doing is I'm using a temp variable, and so it prints something like 4.236, right? It's slowly printing 4.2360 something, right? Do you guys see this? Yeah, so it's printing something closer and closer to 4.236. So again, I could use the same trick. I didn't disturb any of the previous computations. So if you write good code, right? This is the advantage. If you write good code, you can reuse. What does this percentage symbol mean? Looks like somebody asked this. Percentage symbol means when the remainder, when you divide count by 3, the remainder you get. So count percentage 3 gives you the remainder you get. So when I say count percentage 3 equal to 0, that means it's multiple of 3, because we saw that every third number, yeah, it's like mod. So for those of you who know, it's like modulo division. So third number, sixth number, ninth number, 12th number, they are all even numbers. Hence, I'm only printing this sum when they are even numbers, or sorry, this ratio when they are even numbers. And this is the proof of that. So I printed 8. The ratio of 8 divided by 2 is 4. The ratio of 34 divided by 8 is 4.25. 144 divided by 3.34 is 4.235. And if you guys are noticing, this is going closer and closer to the same number, right? All these three look like they're the same number. Hence, again, if I plot this thing again in Excel or in some other plotting tool, this will also look like the same chart we got earlier. So this is also converging. But unfortunately, for those of you who know what it means that it does not converge, the ratio of odd Fibonacci numbers does not converge. Because if I take 13 divided by 5, that's 2.56 or 2.6, whereas 21 divided by 13 is just 1.61. So the ratio of odd Fibonacci numbers, unfortunately, does not converge, whereas the ratio of even Fibonacci numbers and the ratio of consecutive Fibonacci numbers both converge. So for those of you who are doing calculus and other things, these are good examples of where you'll have some interesting things when you have discontinuities in sequences. So this is the same code. We'll share this code again at the end as part of the lecture notes. We'll share this code. So now that we did all this, and we looked at how many things can go wrong with a while loop. So see, while loop when written well is a powerful tool. It's not a inferior thing to a for loop, but when written well, it's a powerful tool. I did not change my while condition after I wrote. It's always been the same for all my other problems. I just kept introducing more ifs and I kept calculating all the other answers. So the code for first question led to the code for second question, that led to the code for third question, and that led to the code for fourth question. I did not solve it 4 different times. Yeah, I'll share the code for each question separately and show you how it went from first question to second question to third question. So we'll share that when we send the lecture notes. But that's how, if you write your code well, you can keep extending. The answer to second question is 125,000 or whatever this big number, 125,862,69025. I'll send at the end of the day or sometime tomorrow. I don't know exactly when I'll send lecture notes. But the answer to second question is that big number. Answer to third question is 1.618 or something like that. So all I did in third question is just divided 2 consecutive Fibonacci numbers, Shruti. I divided fib3 divided by fib2. That's all. So I'm dividing fib3 by fib2. That's it. What is the answer to 3? It is some 1.61803 something something. Okay, so I'll write down all the answers here for once and for all. So answer to, this is the answer to question 1. This is the answer to question 2. This is the answer. Okay, hopefully can. Let me run my loop one more time to get the answer to question 3. So these are the 4 answers for those of you who are interested. These are the 4 answers. I'll also paste in the chat window now. So those are the 4 answers to the 4 questions that we had. But it's always the same code, really. We did not write multiple pieces of code. We just wrote one set of code, really. The questions, yeah, the questions, you want to questions, I'll paste those questions also. So I pasted, hopefully I pasted the questions and send them. Yeah. So I sent the 4 questions and the 4 answers. It will all be there in the lecture notes once we share it like later today or sometime tomorrow. Right. If, for those of you who didn't get these answers, you can try it out yourself. You can try at the end of the class. You can stay a little longer. I'll explain. So now you see while loops are powerful, but they are also fraught with errors, right? Like you make one mistake. There are so many things to make a mistake, right? You could make these many mistakes. Hence, there is another popular loop where it's harder to make these mistakes. Not that you can't make mistakes in that loop. You can still make those mistakes, but it's slightly more harder to make the same mistakes. And that's called for loop. So while loop was this simple looking thing, more like English kind of thing. While this condition is true, keep doing something and keep changing the condition. So it's almost like you start in first grade while you are still less than 12th grade, keep learning and keep going to the next grade. So while, right? So this is as simple as you going to school. Start school, keep going till you finish 12th grade, keep doing some homework or classwork, whatever, go to next grade. But for loop is little more easier and little more shorter. So if I want to do the same thing in for loop, right, the same thing that I did in first problem, which was just this very simple thing of printing the first 10 numbers. So all I did is I printed the first 10 numbers, right? I would do the same thing in a for loop by saying, so for those of you who know, how would I do it in a for loop? For those of you who would know, how would I write a for loop? Okay, for step in range 10. Okay, so there's some of you have given this answer. So let's see, I'll type this exact answer and then print step, right? So it says a syntax error. So let's see, if I run this, it should now print. So do you see that it printed 0 through 9 2 times? So it printed 0 through 9 and 0 through 9. So both my while loop and for loop are doing the exact same work, right? So these many lines of while loop just became these many lines of for loop. So what did I do? This was variable declaration, loop variable declaration, that just became as simple as this, right? It's just typing the variable name instead of declaring it and instead of defining it and declaring it. It just became one step. Then I didn't have, then this print is the same print, but I could get rid of these two things because I use this in range 10. So this in range 10 covers for both this j less than 10 and j equal to j plus 1. So two things that got done in just a very simple in range. So definitely looks shorter, doesn't do any better. It's exactly the same thing as this. If I run this, let's go all the way to a million. Did I type million? So I'll time it. I'll time each execution. So I do import time. Start time equal to time dot time. And then I'll print time dot time minus start time. So this will tell me how long the while loop takes. Then I'll reset start time again and print this. So let's see. It probably takes more time to print all this than to. So let's stop this one and ignore the print. So both of them ran. So it looks like this first one takes about twice as long as the second one. So some call for efficiency. So I'm technically declaring the variable. Oh, can you not see the code?
We can see the code, but not the whole code.
Oh, this is the whole code. Can you see like from import time all the way to print time minus start time?
Yeah.
Yeah, this is the whole code. So while loop versus for loop. If it looks like it takes exactly double or almost double, that's not because while loop takes half the time and for loop takes half the time. That's because I use this clever trick here to say I equal to 0. This is a constant operation, whereas this is an operation. So my while loop is actually doing one extra step than what this for loop is doing really. This code doesn't do anything for most computational purposes. So hence much fast, or exactly double, right? It's like 0.055, 0.113. It's almost double. So that's the story about this. How many of you feel for loop is easier than while loop? Yes, I'm technically, so what I'm doing is, let's map this. So the pieces of a while loop. Loop declaration. In a for loop, the pieces are this. For loop variable declaration. And condition becomes in condition. Or this is condition basically. For loop variable declaration condition. And I don't have to increment. This is also the increment loop instructions. So I did everything related to the loop variable declaration, loop statement, loop variable change, everything in one statement. Right, both are good, yeah. So whichever is easy, it depends on what you're coding. So if you want to go through a loop, sometimes this is easy, sometimes this is easy. It's almost like they do the same kind of thing, but slightly differently. So it's best if you know both. But after some period of time, most likely you will be more biased towards one over the other. So basically the three things related to the loop in a for loop, in a while loop went into the same line on a for loop. Hence it is very difficult to make mistakes, right? So if you forget this, you'll still get an error. If I forget typing that, I'll still get the same variable and invalid syntax, right? So it will still give me an error, but since you're typing all of this in one line, the hope is you'll not make as many mistakes. Now in the next 10 minutes or so, an easy question for all of you to try so that you can practice for loops. So this is how you practice for loop, or like you can print the first million numbers. So I'll just print 100 numbers. So I would like for you guys to find the sum of first 1000 natural numbers. So all numbers starting from 1 to 1000. Sum of first 1000 natural numbers using a for loop. So all of you please try in the next 5 to 10 minutes. Sum of first 1000 natural numbers using a for loop. Oh, so find sum of first 100 natural numbers using a for loop. Can you see the question now? Find sum of first 100 natural numbers using a for loop. Those of you who got the answer, you can start sharing your answer in the chat window. Shruti, really? That's all? Shruti, it can't be less than 500,000, right? So you're missing one number. Satvik Adimulam, you're missing one number. Right? Because the sum of first 10 natural numbers is n times n plus 1 by 2. So 1000 times 1001 divided by 2 is 500, 500. Not 499, 500. So you missed adding 1000 really to your answer. So Satvik, you calculated the sum of first 999 numbers, not sum of first 1000 numbers. Yeah, 500, 500, yes. Yeah, don't share code, please don't share code. $500,501. Wow, how is that possible? You must have started your sum equal to 1. When you started, did you say sum equal to 1? Oh, sorry, first 1000. I'm very sorry. I typed 100 here. 1000, sorry. First 1000. Good, Rohan. That's correct answer. Simran, you also didn't add 100, the last number, which is 1000. Simran, you also went all the way up to 999. Meghna, your answer is correct. Nipun, it looks like you started with sum equal to 1 instead of sum equal to 0. No, 499,500 is not the correct answer, Nipun. It's, yeah, that's the correct answer, Darren. Yeah, that's correct answer, Nipun Tanvi. That's the correct answer. Yeah, absolutely, Aditya. That is the correct answer. Okay, correct, smooth. So now looks like most of you guys are getting for loops correct. Yes, absolutely. So Luigia son, that's a good observation. For loop actually starts with 0. It's not really for loop per se that starts with this 0. The range function starts counting from 0 when you don't tell it to start counting from 1. So all of you after the class probably read up on the range function. If you Google Python range, I'm sure you'll find tons of articles. Whichever you like, you can Python. I like this particular book because that was one I used long time ago when I really first time learned Python. I like this book called Bite of Python by an author called Swarup Chandrasekhar or someone. So Bite of Python. So it's almost like playing on the same with Python, right? Python bytes. So this book is pretty good. It's free and it's available online. It's an old book actually. I think this one, the first book came out in 2004 or something. So it's a very old one, and they have kept on writing newer versions of it. So it's pretty thorough book. But you can use any other online thing that you find. So range W3 schools is also pretty good. You can use that. You can use even Python's own website. Python has a very good documentation. Yeah, Who is getting, oh, you are adding 1001 to the answer, Monishka. You're adding one more extra number. You're adding an extra 1001 to your answer. Okay, so let's see, because we only have about 12 more minutes left. So I'll solve the problem now. So for those of you who got initially some answer, the answer is as simple as saying for I in range, you probably started off by this for I in range 1000, sum equal to 0, right? Some of you have started with sum equal to 1, but that's not correct. Sum equal to 0, sum equal to sum plus I. Yes, Shruti, Satya, that's the correct answer. And then you printed sum. So if you do this, you'll get 4, oops, I made some mistake. I typed ID. So if you do this, you got 499,500. But the sum of first 1000 numbers is really 1000 times 1001 divided by 2, which is this 500, 500. So what I missed is basically this range function. So this range function stops at 999 really. Once it reaches 1000, it doesn't go into this loop. That's the problem. So if I want to include the 1000th number, I have to make my range go all the way to 1001. Seemingly odd thing, but programming wise the right thing to do, because the minute it reaches 1000, it stops, it doesn't continue. And if you want to continue include 1000, you have to do this way. So when I do this, I got my correct answer. Some of you looks like you went all the way to 1002. If you do that, you get 501, 501. Some of you started sum with 1. You do that, you get 500, 501. Oh no, why are we dividing by 2? That's the same Gauss-based sum of a sequence method that I discussed last time, right? Take the first number, add it to the last number, take 1, add it to 1000, and then pair up 1000 divided by 2. What does sum plus I mean? Each number, when I say for I in range of 1001, inside this loop, I goes through the values 1, 2, 3, 4, 5, 6, and so on. It goes from 1, 2, 3, 4, 5, 6. And each time the loop statement gets executed, I value increases by 1. So you start with for I in range 1001. That's exactly what we did, right? So let me try a smaller loop. So I'll try for I in range 10, and then I say print I. So you don't have to do any loop increment or anything, it prints. So it starts with 0. First time it prints 0, then increases by 1, prints it, increases by 1, prints 2, and goes all the way to 9. Once it reaches 9, it increases to 10 and then stops it. It doesn't print 10. So you can't just do for I in range I equal to I plus 1. So Sai Satya, so that's a good question. If I do this, right, I equal to I plus 1, if I do this, I'm changing the loop variable, right? I'm not changing the sum. So if you do this, if any one of you have done this, you're trying to add up to your own loop variable. You're not calculating the sum. So you need a separate variable. It's almost like saying, if I want to add up 1, 2, 3, 4, 5, up to 10, would you do 1 plus 1 plus 1 plus 1, or would you do 1 plus 2 plus 3 plus 4? So you don't have to do I equal to I plus 1. That is automatically taken care of in the for I in range. You just can do sum equal to sum plus I, or I plus sum, whichever you prefer. And start with at 0, so that you declare the sum, which is a separate variable. So start with sum equal to 0, and then you do this. Can I run this? Yeah, I can absolutely run this. So, oh, I didn't print anything, so it's not showing anything. So if I print sum, this will now print 45. If I want to print the sum of first 10 numbers, which most of you probably know is 55, I have to go all the way up to 11. If I want to do up to 1000 numbers, I have to go all the way up to 1001. That's 500, 500. Yes, Shreyan, what is your question? Okay, no problem. Okay, so now in the last 7 minutes of the class, we'll discuss homework and also what mistakes you guys made in submitting the homework last time. It looks like at least there are 3 or 4 commonly made mistakes. Not necessarily mistakes. Shruti, if you do I equal to I plus 1, right? You don't you stop the loop much faster. Can you manipulate the range function? Range function you can't manipulate, but you can manipulate the loop variable. See, if you do what Shruti is suggesting, right? If I do I equal to I plus 1, let's go only up to 11. Let's see what this prints. So it printed 66, right? It should have printed 55. So it went little one more extra step. No, 66 is not right. This is only going up to 11, right? When I remove this, it's showing 66 because it added 11 more things. If you want to find the sum of first 10 numbers, you have to do range up to 11, right? What Shruti's code did is basically she added 1 to every number that you're coding, right? Prints and it when you say I in range 11, let me just print to show you what it prints. It doesn't print 11 when I go up to 11, it prints only up to 10. Did it print 11 prints here? So while it looks like I am showing up to 11 numbers, it is only up to 10 numbers really, because the loop only runs 11 minus 1 times. Yes, no, it can add any number of numbers, Luigi's one. So if I want to go up, increase by two numbers. So I can say I start with 1, go all the way to.
Karthik, the 0 based versus 1, maybe the students are getting confused.
No, this is the end number, right? Even if we start with 0, this one it won't include. So that's the. So if I start with 0 or 1, it won't include the 11 really. So if I put this as 1. So when you put this as 11 here, so what this is, the range function has 3 arguments. What is the starting number? What is the ending number? And how much should I increase in each loop? Should I increase in 1 or not? The fact that it starts with 0 has nothing to do with why it goes only up to 11. The fact is because the loop only goes to less than 11, and 11 is not less than 11. 11 is equal to 11, right? So it's the way this loop works. It starts with I equal to 0, goes to I less than 11, incrementing by 1 each time. So that's the reason why it's a problem. Even if I start it with 1, it wouldn't do any different, right? So it now went from 1 to 10. See, the end point is 10 always. Even though you see 11 here, it ends at 10. Slightly confusing, but the way to read it is starting with 1, going all the way up to 11, but not including 11. And then printing, incrementing by 1. So if I want to increase by 2, I can increase by 2 also. Somebody asked in the chat window, right? You can do whatever increment you want. If the increment is too high, it won't increase at all. So if I increase by 20, it won't print anything. Or sorry, it still prints the first one because the first time it will work, but after that it doesn't print. So is this clear? So for I in range has 3 parameters: starting value, ending value, but not including the ending value, and then a jump. So start here, go all the way up to here by jumping by this much. If you don't include these 2 extra parameters, it assumes you are starting from 0 and goes increasing by 1. That's why you got this, right? Starts from 0, increases by 1. So that's what the function assumes. Okay, now any questions? Okay, so for loop looks simpler, but is also risky sometimes. Yes, class is over. Now we'll discuss homework and how not to submit your homework, because a lot of you came up with different ways to submit homework. We can discuss your scores later, please. Don't worry about discussing your scores now. Scores is after the class. So first question in your homework. find the sum of first 1000 natural numbers. This is what you did in classwork already. Find the sum of first 1000 natural numbers. Then find the sum of squares of first 1000 natural numbers. Again, very easy, nothing interesting. You have to calculate 1 square, add it to 2 square, add it to 3 square, add it to 4 square. Then find the sum of cubes of first 1000 natural numbers. Then calculate difference of, can you please scroll? Yeah. Difference of sum of squares minus sum of first 1000 natural numbers. So whatever you calculated, oops. Whatever you calculated in problem 1, problem 2, subtract it from problem 1. What if you have a geometric progression? So Lucia, increasing a loop in a geometric progression, a for loop is useless. A for loop is useless to do geometric progression. You need to use a while loop for geometric progression. Okay, so calculate difference of sum of cubes of first 1000 natural numbers. How many of you know what's the answer to this fifth question already? You can solve whatever way you want, but if you want to use for loops, that's best. How many of you know for number 2, do we, yes, Tanvi, you have to go from 1 square plus 2 square plus 3 square. So for first question, you're doing 1 plus 2 plus 3 plus so on up to 999 plus 1000. For second question, you are doing 1 square plus 2 square plus so on. For third question, it's 1 cube plus 2 cube plus 3 cube. So how many of you, so this is really just for loops easily. This will be posted, yes, this will be posted to the website. I'm just explaining so that if you have any questions, you can ask now so that you don't have to keep emailing us right after you see the homework. So 5 questions, sum of first 1000 natural numbers, sum of first 1000 squares of 1000 natural numbers, cubes of 1000 natural numbers. Subtract this from this, square this and subtract from this. Okay, no report. If you say no report, then I'll have to give more harder questions then. What does the difference of sum of squares mean? Calculate, okay, see this. Calculate sum of squares. So calculate these things. So basically answer to question 2, easy. Yeah, this is pretty easy, right? Do you guys want easy questions and a report or hard questions and no report? You can choose.
Easy questions and a report.
Okay, looks like that's the more unanimous one. So far, hopefully these questions are easy. The fourth question is basically subtract the answer of first question from second question. That's all. Answer for second question, answer for first question. Subtract them. Fifth question is take the answer for third question and square the answer for first question and subtract it. How many of you know what is the answer to this question already? Some of you might probably know what is the answer to fifth question. Any of you? Okay. Oh, perfect. Yeah, Vidyut, yeah, correct answer. So somebody seems to know. Okay, yeah, the answer to fifth question is 0 if you want to know. I'm giving you the answer because I'm sure you will all find it. But code it and find out. This is also called as Nicomachus formula or Nicomachus sequence. It's a 2000-year-old Greek discovery that the sum of the cubes of natural numbers is equal to the sum of natural numbers whole squared. So sum of the cubes is n times n plus 1 divided by 2 whole squared. So this homework is probably very easy. I don't know if I can go easier than this. The only thing that I would add here is find the 1001st Fibonacci number. So that's it. So 6 questions and a report, a one-page report of what we heard in this class. Any questions? So 6 questions and a report, at least 1 page long. Now for the submission instructions, I'll include an example of what to do. Please stay a little longer for submission instructions. It looks like a lot of you last time submitted a PDF on Agora Math Circle's website. Yeah, we are going through how to submit your homework, and if you make the same mistake as some of you guys made the last time we reached out to you, we asked for something and gave points. This time if you guys don't follow homework submission instructions, we'll give you 0. So homework submission, your report should be in a PDF format. Write up your 1-page report in a PDF format. In that report, either at the beginning of the report or at the end of report, include a link to your collab session. So the collab page where you wrote your code. Do not include code, because if you include code, we will not run your code to check if it is correct. So you have to include code, the link to your code, and share your workbook with everybody. So if I don't know if you can still see my screen, but you have to share it with, you can copy link and change this to say change to anyone with the link. So now it would show you this, anyone with the link. Then copy this link. So we'll discuss your class homework feedback little later. Whoever wants to know what their homework feedback is. Yes, I already posted this under homework instructions last time, but still most of you guys skipped it. So make sure you're sharing it with everybody, and then copy this link and paste it in the PDF. If you do not do this, you will not get any points for your first 6 questions. You'll only get points for report. If you don't use Collab, please copy paste it into either repl.it, type up your code wherever you want. For those of you who don't use Collab, go to repl.it. Put it in some online code editor and then share the link from there. Python. So you can go to repl.it Python code and then paste your code here, and then you can create an account here and share it. But these are the only 2 links which we will accept. Yeah, there is probably an option to share Ripple always, but as a PDF, include a link either on repl.it or in Collab. Only those submissions will get you points. Otherwise, we will not give you points. We will not be reaching out to you and asking you to share your code and so on. And the final thing I think that we noticed is some of you were submitting your homeworks to your Agora Math Circle account. if you guys are enrolled in both Agora Math Circle and Agora Engineering Circle, please make sure you choose the class when you're submitting, the right class when you're submitting your homework. If you are not sure how to do it, let me see if I can log in with one of the accounts. So this is a test account which I have. So let's see if I go. Yes, I know you have a drop down under your name. Absolutely. Yeah. Those of you who know, yes, you can drop off. Thank you for joining. Yeah, we are going over time. Yes, because people also started a little late. Maybe I'm typing the password wrong. Let me try one more time. If I can't, yeah, I'm probably typing something wrong. Okay. If you know how to submit your homework, if you know what is expected of your homework, you can all drop off. I don't know who is the highest score. We can probably discuss that next time. Who got the highest score? Yes. I'm having an issue logging into my test account. So anyways, once you log into your account, you'll have a drop down to choose which course you are submitting the homework for. Please choose the right course and submit. So please avoid the 3 mistakes. Use the link in the report and share the collab session as well as submit it to the right class. There is an LK. Oh. Let's see one more time. Okay, that's okay. Yeah, yeah. Shreya, maybe if you can share, try sharing and show, because I'm somehow not able to log in. Maybe I'm using the, oh, password is different. Okay. Yeah, let me try this password. Oh, okay. Yeah, so it looks like now I was able to log in. So when you're uploading your documents, what to say wrong. I think I may have stopped sharing the screen accidentally. So share again. So enrolled into 2 things, senior advanced and art AI class. You are uploading a document. Make sure you choose the right class here. If you submit to the wrong class, last time we switched it, but this time we wouldn't be. Thanks a lot for joining.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the at.